The story begins with an eerie stillness that blanketed the Pacific skies before dawn, where U.S. pilots would soon learn a secret so radical it would change aerial warfare forever. A technique that seemed reckless, almost suicidal at first glance, intentionally killing their engines mid-flight, throttling them to near silence while trusting the fragile airframe and sheer skill to carry them further than anyone had ever thought possible. And it all started with the desperate lessons learned from countless combat missions where fuel ran perilously low, and crews faced the terrifying calculus of distance, weight, and survival. In those first critical moments, the cockpit was a tension chamber, gauges flickering, engine noises subdued, and the silence that followed seemed almost unnatural to seasoned pilots who were trained to fight every rumble and roar. Yet they had discovered that the engines, when killed or throttled back just enough, consumed far less fuel, producing a glide that could double the operational range of their aircraft. A revelation born not from manuals or orders, but from sheer necessity and the improvisational genius of men who understood that in the unforgiving expanse of the Pacific, inches and seconds could mean life or death. And so they experimented quietly, daring each other to trust this counterintuitive method, learning the precise angle of glide, the subtle manipulation of airspeed, and the delicate balance between engine power and wind currents that would allow them to drift silently over enemy-held islands or stretch their bomb runs far beyond the expected limits of the aircraft, their comrades watching anxiously from other planes, aware that any miscalculation could send a bomber plummeting hundreds of feet before anyone could intervene. Over time, pilots refined this method into a systematic practice, documenting throttle adjustments, altitude variations, and weight management, realizing that by partially cutting power while maintaining lift, they could essentially pause fuel consumption while still staying aloft, transforming the very physics of flight into a strategic advantage, allowing long-range reconnaissance, extended bombing missions, and escape from enemy fighters who were baffled by these ghost-like approaches. As the gliding bombers appeared to defy the normal limits of aircraft design, their engines barely audible over the wind, shadows gliding across the ocean like silent predators. And it was in these early trials fraught with danger that lessons were learned about engine cooling, propeller pitch, and the minimum airspeeds necessary to prevent stall. Every flight a living experiment, pushing both human and machine to their utmost limits. As the war intensified, these techniques became essential knowledge, a quiet revolution in aerial tactics, allowing bombers to carry heavier loads farther distances, giving commanders the ability to strike targets previously considered out of reach. And yet the pilots who first practiced these methods carried the weight of risk every time they throttled down, knowing a single miscalculation could result in catastrophic engine failure or uncontrollable descent, a reality that sharpened their reflexes, honed their judgment, and turned routine flights into calculated exercises of courage, skill, and intuition. Stories from veteran airmen describe the surreal sensation of watching other engines scream past while their own aircraft coasted almost silently, skimming above waves, forests, or enemy positions, the wind filling the cockpit, instruments vibrating subtly, and the unnerving quiet amplifying every thought, every heartbeat, until the first successful extended flight proved beyond doubt that this risky approach could revolutionize air warfare, doubling the effective range without sacrificing payload, allowing for daring missions into territories that would have previously required refueling stops or lighter bomb loads. Mechanics on the ground would meticulously study these flights, noting unusual wear patterns on propellers, fuel lines, and engine mounts, as the deliberate throttling caused strain on components not anticipated in standard operating procedures. Yet their findings enabled engineers to suggest minor adjustments, reinforcing airframes, recalibrating gauges, and optimizing throttle response to make the engine kill technique safer and more reliable, while training manuals quietly began to incorporate these lessons, spreading knowledge across bomber crews, so that what started as individual improvisation evolved into an institutional practice, giving U.S. pilots an unprecedented operational edge. Over months of deployment, the effectiveness of these methods became undeniable, as crews returned from missions with heavier payloads, longer flight distances, and survival statistics that outperformed previous campaigns, creating a strategic ripple effect. Enemy defenses were caught off guard, supply lines disrupted farther inland, and intelligence gathering improved dramatically because reconnaissance planes could now cover twice the territory without refueling. Meanwhile, pilots developed subtle variations, including partial engine kills, intermittent throttle bursts, and even synchronized glides across multiple aircraft to maximize fuel economy while maintaining formation integrity, allowing squadron leaders to coordinate maneuvers that bewildered opponents, turning theoretical physics into practical wartime advantage. And with each mission, the legend of killing the engines spread quietly among airmen, becoming a rite of passage, a technique taught only under supervision, reserved for the bravest who understood both the peril and the extraordinary reward of mastering their machines in ways their designers had never intended. Commanders observed these flights with a mixture of awe and cautious approval, realizing that the disciplined execution of engine throttling could extend mission range, reduce exposure to anti-aircraft fire by allowing gliding approaches, and enable crews to punch deeper into enemy territory than ever before, effectively rewriting the boundaries of operational strategy while simultaneously pushing aircraft technology to its breaking point. The psychological impact on pilots was profound, as the silent glide required total trust in instruments, airspeed calculations, and intuition, cultivating heightened situational awareness, precision coordination with fellow crew members, and a calmness under pressure that became invaluable in combat. With every successful mission, new refinements emerged: engine cooling schedules, glide angles optimized for load and altitude, and emergency recovery protocols, transforming what began as a dangerous improvisation into a disciplined, codified procedure that would be used throughout the Pacific theater, allowing U.S. pilots to strike, retreat, and reposition with unparalleled efficiency. And as the war progressed, stories circulated of aircraft reaching previously impossible ranges, crews gliding silently over enemy positions while conserving precious fuel, returning to base with payloads intact, and sometimes landing with engines barely running, a testament to human ingenuity, courage, and the audacity to exploit physics in ways never taught in any classroom or manual. A daring gamble that changed the dynamics of aerial warfare forever and left pilots, engineers, and commanders alike marveling at how deliberately killing an engine could transform ordinary bombers into ghostly vessels capable of stretching across oceans and continents. And in these stories, full of tension, near misses, and triumph, lies the enduring suspense. The very idea that machines designed to roar could be silenced, yet carry men farther than ever before, a quiet defiance of expectation, a lesson in ingenuity that doubled the reach of American air power, proving that sometimes survival and dominance require not more firepower, but controlled silence, discipline, and an unflinching willingness to push both man and machine to their limits. Before the sun had risen over the endless expanse of the Pacific, the bomber crews of the U.S. Army Air Forces prepared for what would become a radical transformation of aerial strategy, a method so daring that initially only the most experienced pilots dared attempt it, deliberately throttling engines to near silence to conserve fuel, a technique that, if miscalculated, could send a fully loaded bomber plummeting into the ocean or onto an uncharted island, yet offered the tantalizing reward of doubling their operational range, a measure of distance that would allow them to strike deep into enemy territory, conduct reconnaissance over previously unreachable targets, and return home with lives and payloads intact, a concept born from months of painstaking trial and error flights, where crews faced the harsh reality of dwindling fuel, unpredictable weather, and enemy engagement, and realized that the conventional use of engines, always at full throttle, unnecessarily limited their reach and exposed them to unnecessary danger. The first attempts were marked by tension so thick it could be felt in every movement, every breath in the cockpit, as pilots carefully reduced engine output while maintaining altitude, their hands gripping the controls with a combination of fear and determination, listening intently to every vibration, every subtle sound of machinery, learning to interpret minute fluctuations in RPM, fuel pressure, and airspeed as signals for survival. And through painstaking observation, they discovered that a carefully controlled engine kill did not mean complete silence or loss of power, but a delicate reduction that allowed the plane to glide efficiently while consuming minimal fuel, a technique that required synchronization between pilot, co-pilot, navigator, and bombardier to maintain course, monitor enemy positions, and execute their mission with precision, because even the smallest misjudgment could result in stalling, uncontrolled descent, or catastrophic engine failure. Over weeks of practice, this method evolved. Becoming more than an improvisation, it became a strategic advantage, a calculated gamble that transformed the very nature of air operations, allowing bombers to carry heavier payloads over longer distances than previously thought possible, and forcing commanders to rethink mission planning, risk assessment, and engagement strategies, as the ability to extend range without additional fuel fundamentally changed the operational map of the Pacific theater, enabling strikes that had once seemed logistically impossible, and allowing reconnaissance planes to map enemy fortifications, troop movements, and supply lines with unprecedented scope. The pilots quickly learned that the technique demanded both skill and courage, as throttling engines shifted the aircraft's center of gravity, altered handling characteristics, and required constant vigilance to avoid stalls during critical maneuvers, a lesson underscored by near misses during early missions where crews returned with engines overheating, wing flaps strained, and landing gear stressed to its limits. Yet each successful glide reinforced the value of the approach, teaching crews to read the sky, wind currents, and altitude with the precision of seasoned aviators, transforming every mission into a masterclass in both aerodynamics and calculated risk-taking, where instinct, observation, and meticulous preparation determined survival. Mechanics on the ground became integral to the process, analyzing wear patterns on engines and propellers caused by throttled flight, recalibrating instruments to provide accurate readings at lower power settings, and reinforcing airframes to withstand subtle but cumulative stresses, ensuring that each subsequent mission could safely push the limits further. While engineers documented every parameter, noting the exact throttle settings, glide angles, and airspeed combinations that maximized range without compromising structural integrity, essentially codifying what had begun as a dangerous improvisation into a repeatable, teachable method that could be deployed across multiple squadrons with remarkable consistency. The impact on operational planning was immediate and profound. Targets previously considered beyond reach were now accessible. Sorties could be extended without additional refueling, and enemy defenses were caught off guard as bombers appeared to glide silently over territories that had been assumed safe. A psychological advantage as much as a logistical one, creating uncertainty and forcing the Japanese military to rethink the placement of anti-aircraft artillery and fighter patrols. As the increased range and unexpected flight profiles defied their predictions, a direct consequence of the pilots' daring adoption of engine throttling and glide management, proving that ingenuity and discipline could overcome apparent mechanical limitations. Beyond tactical advantages, the technique fundamentally reshaped the relationship between pilot and aircraft, requiring an intimate understanding of engine behavior, fuel consumption, aerodynamic efficiency, and environmental factors such as wind, temperature, and humidity, demanding that every crew member participate actively in monitoring, decision-making, and course correction, cultivating a level of coordination and trust that transformed squadron operations. As pilots who mastered engine kills became mentors for others, sharing nuanced insights about glide angles, partial throttle management, and the subtle interplay between payload, altitude, and airspeed, building a culture of adaptive, evidence-based practice that extended beyond the Pacific theater, influencing bomber operations globally. Stories from these missions became legendary, pilots describing the eerie silence as engines hummed quietly, the feeling of coasting above enemy territory with minimal mechanical noise, instruments vibrating subtly under reduced load, while below, flak and fighters moved obliviously, unaware that these ghost-like planes could carry double the payload farther than previously imaginable, a combination of calculated risk, precision engineering, and nerve that blurred the line between human ingenuity and machine capability. and each successful flight reinforced the principle that controlled engine throttling, far from recklessness, was a disciplined strategy demanding skill, timing, and intimate understanding of both physics and machinery, a lesson that would become an essential part of bomber training, permanently altering aerial strategy. As the months progressed, pilots refined variations of the technique, experimenting with partial throttles, intermittent bursts of power, and coordinated glides across multiple aircraft, optimizing formations to maximize fuel efficiency while maintaining operational cohesion, allowing squadron leaders to plan longer missions with heavier payloads and reduced exposure to enemy detection, a transformational approach that expanded the theater of war, increased mission success rates, and reduced losses, while simultaneously testing the resilience of the aircraft and the endurance of the crews, who learned to remain calm under extreme conditions, monitor every subtle change in instruments, and make instantaneous adjustments to sustain flight and avoid disaster. Mechanics and engineers meticulously recorded every flight, noting abnormal stress patterns, engine temperature fluctuations, and structural wear induced by low-power operations, enabling incremental design improvements to support the engine kill technique, from reinforced control surfaces to optimized fuel mixtures, propeller pitch adjustments, and improved instrumentation, ensuring that planes could safely execute these daring strategies without compromising crew safety. A synthesis of pilot skill, engineering insight, and disciplined methodology that became a defining characteristic of U.S. bomber operations. In the final analysis, the engine kill method not only extended flight range but also enhanced survivability, operational flexibility, and strategic reach, enabling American pilots to strike further, gather intelligence over previously unreachable areas, and return safely with heavier payloads, creating a cumulative advantage in both tactical and psychological terms over enemy forces, who could not anticipate the ghost-like approach of these aircraft, nor the disciplined ingenuity that allowed men to harness the engine's limits, effectively turning what had begun as a desperate improvisation into a cornerstone of modern aerial warfare doctrine, and leaving a lasting legacy, the understanding that human skill, when coupled with careful observation, experimentation, and daring, could redefine the limits of machine performance, transforming ordinary bombers into instruments of extended reach, precise power, and silent dominance, and ensuring that the lessons of these missions would resonate for generations, a testament to courage, intellect, and the audacity to push beyond conventional limits even when the stakes were life and death. The next evolution of the engine-killing technique emerged during the harshest stretches of the Pacific Campaign, where pilots faced the unrelenting challenge of extended missions over open ocean, where miscalculations could lead to catastrophic fuel exhaustion and the cold, unforgiving sea below. And it was in these extreme conditions that the true potential and danger of deliberately throttling engines became evident, as crews learned to manipulate throttle settings not just to conserve fuel but to optimize performance under variable wind currents, air density changes, and unexpected weather patterns, transforming every flight into a precise exercise in aerodynamics and nerve, with the cockpit becoming a theater of silent tension, instruments flickering, gauges trembling, and every minor vibration scrutinized because a single lapse in concentration could result in stall, engine failure, or uncontrolled descent. And yet the rewards were undeniable. Aircraft could fly farther, carry heavier bomb loads, and return home when previously the same journey would have left crews stranded in the expanse of the Pacific, a testament to the audacity and skill of men willing to risk everything to master the delicate balance between machine and physics. During these missions, pilots developed nuanced variations of the technique, including partial throttling, intermittent bursts, and micro-adjustments to engine RPM based on altitude, payload, and prevailing winds, while bombardiers and navigators carefully recalculated flight paths in real time, ensuring that glide angles and descent rates maximized efficiency without compromising mission objectives. A dance of human skill and mechanical endurance that required absolute coordination, heightened situational awareness, and split-second decision-making, as one wrong move could undo hours of careful navigation and thrust conservation. And yet with each flight, crews grew more confident, learning the subtle cues of engine sound, airframe vibration, and control surface response, refining the method into a disciplined, repeatable procedure that extended not just flight distance, but operational capability, forcing military strategists to recognize that innovation born from necessity could alter the very calculus of war. Mechanics and engineers on the ground played an equally critical role in this evolution, meticulously examining engines, fuel systems, and airframes for the subtle signs of strain caused by prolonged low-throttle operation, adjusting propeller pitch, lubricants, and fuel mixtures to ensure reliability, while reinforcing structural elements to accommodate the stresses induced by extended glides, an iterative process of observation, analysis, and modification that married theoretical aerodynamics with practical field experience, allowing each successive mission to push the limits safely further, and ensuring that what began as a desperate improvisation became a systematic, strategic advantage that could be taught, replicated, and perfected across multiple squadrons, a transformation that turned individual ingenuity into institutional capability. Stories from these missions highlight the extraordinary courage and precision demanded by the technique. Pilots recounting the eerie silence as engines hummed quietly while their planes coasted above enemy territory, flak bursting below, fighters unaware of their presence, instruments vibrating subtly under the reduced power load, the horizon stretching endlessly, and every adjustment of throttle, flap, and rudder a potential difference between safe arrival and disaster, a combination of skill, calculation, and nerve that transformed routine missions into suspenseful exercises in both physics and survival, as crews learned to anticipate airflow, wind shear, and thermals, exploiting them to maintain lift and extend range, often gliding for miles over hostile territory before gently bringing engines back to life to continue their journey. As pilots became proficient, coordinated tactics evolved. Squadron leaders synchronized throttling maneuvers across multiple bombers, balancing fuel conservation with formation integrity, reducing noise, minimizing visual detection, and surprising enemy defenses with ghostly arrivals at strategic locations. An unprecedented advantage that extended not just individual mission capability but the operational reach of entire campaigns, allowing American forces to hit targets previously considered unreachable, conduct reconnaissance over vast swaths of ocean and islands, and return with both crew and payload intact, fundamentally changing the strategic map of the Pacific theater and redefining what was possible with existing aircraft. The psychological effect on pilots and crews was profound. The quiet glide demanded total concentration, absolute trust in instruments, and seamless communication among all on board, fostering heightened situational awareness, quick decision-making, and disciplined risk management, traits that would carry over into all aspects of aerial operations, creating a new standard of professionalism and courage under pressure. As each successful flight reinforced confidence in the method, and each challenge overcome contributed to a growing body of institutional knowledge that would outlive the war. Simultaneously, engineers documented every nuance of the technique, creating manuals and procedural guides that detailed exact throttle settings, glide angles, and optimal conditions for partial engine shutdown, transforming what had been improvised experimentation into codified practice, ensuring that new crews could adopt the method safely and effectively, while mechanics devised maintenance routines specifically to address stresses unique to engine-killing maneuvers. From monitoring cylinder temperature to checking propeller alignment, fuselage strain, and hydraulic performance, creating a comprehensive system that combined human skill, technical knowledge, and mechanical optimization to maximize both performance and safety, and ensuring that the technique's success was replicable, reliable, and sustainable across the bomber fleet. The operational implications were staggering. Missions that once required careful fuel rationing, lighter payloads, or multiple refueling stops could now be conducted with heavier bomb loads, longer ranges, and reduced risk, allowing strategic planners to extend the reach of American air power, penetrate deeper into enemy territory, and conduct sustained campaigns without the limitations imposed by fuel logistics, fundamentally altering the dynamics of warfare in the Pacific. Tales of these missions became legend, crews describing the surreal experience of silent flight over enemy positions, the tense calculations of glide versus throttle, The eerie contrast between the humming of the engines and the roar of distant anti-aircraft fire, and the overwhelming satisfaction of returning home with both plane and payload intact. A tangible reward for mastering the delicate balance between human ingenuity and mechanical endurance, and a testament to the combination of courage, innovation, and rigorous practice that defined the American bomber crew's approach. Ultimately, these experiences proved that deliberately killing or throttling engines was not recklessness, but calculated strategy, a method that doubled operational range, conserved precious resources, and enabled unprecedented mission success, transforming the physics of flight into an actionable, strategic advantage, leaving a lasting legacy for military aviation. A lesson that survival, dominance, and victory sometimes depend not on more firepower, but on control, precision, and the courage to exploit limits in ways few would dare, and embedding a cinematic, suspenseful narrative of skill, danger, and triumph into the annals of aerial warfare history. A story of men who learned to fly farther, smarter, and more efficiently by embracing the silent power of their machines and redefining what was possible in the skies above the Pacific theater. As the Pacific campaigns intensified, pilots began to refine the engine-killing technique into an art form that combined daring, precision, and an almost instinctual understanding of their aircraft, a method that transformed routine missions into tense, suspense-filled operations where every decision mattered, and where the margin for error was measured in seconds, feet, and gallons of fuel. And it was in these extreme conditions that crews discovered the full potential of controlled engine throttling, where the subtle reduction of power allowed bombers to glide silently over enemy territory, conserve fuel, and extend operational range dramatically, effectively rewriting the rules of aerial warfare while simultaneously placing immense demands on human skill, courage, and coordination as pilots learned to balance engine output, payload weight, altitude, wind currents, and airspeed, creating a delicate dance of aerodynamics that required total focus, flawless judgment, and intimate trust in both instruments and crew. The process began with meticulous pre-flight calculations, where navigators and flight engineers determined the optimal glide paths, throttle reductions, and altitude profiles necessary to achieve maximum range without compromising safety, integrating meteorological data, payload considerations, and enemy positions into every decision, while pilots memorized subtle cues from instruments, engine behavior, and airframe vibrations that could indicate impending stall, overstrain, or mechanical failure. A continuous mental and physical engagement that transformed the cockpit into a chamber of heightened tension and awareness, where silence was not merely golden but essential for survival. During these extended missions, pilots discovered that throttling engines to carefully measured levels created an almost ethereal glide, allowing bombers to coast over vast stretches of ocean, islands, and enemy installations with minimal mechanical noise, a tactic that caught anti-aircraft defenses and fighter patrols off guard, as they were trained to detect roaring engines rather than near-silent gliding aircraft. And this unexpected element of stealth enhanced mission success while simultaneously extending the effective operational radius of the bombers, providing a strategic advantage that commanders had never before imagined, and allowing American forces to strike deeper, gather critical intelligence, and return with both crew and payload intact, a feat that redefined what was logistically possible in the theater. The human element was as critical as the mechanical, as pilots, co-pilots, bombardiers, and navigators developed an unprecedented level of coordination and trust, communicating in hushed tones, constantly adjusting throttle, rudder, and flaps to maintain optimal glide paths, while simultaneously monitoring enemy positions, environmental factors, and fuel consumption, a ballet of human skill and machine response that required total mental focus and physical precision. And every successful flight reinforced the crew's confidence, teaching them to interpret the subtle nuances of engine sound, airframe vibration, and wind behavior, turning intuition into a refined operational skill set, and creating a cadre of aviators capable of exploiting the aircraft's limits to achieve extraordinary results. Ground crews and mechanics played an equally crucial role, analyzing wear patterns, engine performance, and structural strain after each sortie, developing maintenance protocols specifically to support prolonged low-power operation, reinforcing airframes, recalibrating gauges, and modifying fuel lines, propellers, and hydraulics to withstand stresses induced by engine throttling. Essentially engineering a system that integrated human skill, mechanical optimization, and procedural discipline into a cohesive strategy that could be safely replicated across multiple squadrons, ensuring that what had begun as improvisation became institutional knowledge and a standardized, teachable approach that maximized operational efficiency and mission success. As the technique matured, variations emerged. Pilots experimented with intermittent engine bursts, coordinated glides across multiple aircraft, and precise throttle modulation to maintain formation integrity while extending range, allowing squadrons to penetrate previously unreachable enemy territory, surprise defenders, and execute bombing runs with unprecedented effectiveness. A combination of risk, skill, and calculation that blurred the line between human ingenuity and machine capability, demonstrating that aircraft could be pushed beyond conventional limits without catastrophic consequences when handled with knowledge, discipline, and courage, and turning seemingly impossible missions into achievable, repeatable operations that transformed the strategic map of the Pacific theater. Psychological resilience became a hallmark of crews employing this method, as the quiet glide, the eerie hum of throttled engines, and the constant awareness of potential disaster honed concentration. Calmness under pressure and decision-making speed, traits that proved invaluable not only in executing the engine-killing technique, but in every aspect of aerial combat, fostering a culture of precision, situational awareness, and mutual trust among crew members, a combination of mental fortitude and technical mastery that became as critical to mission success as any mechanical or logistical factor. Through repeated sorties, pilots documented and refined optimal glide angles, partial throttle settings, and emergency recovery procedures, effectively codifying a revolutionary approach to flight management that combined aerodynamics, fuel conservation, and tactical deception, ensuring that new crews could adopt these methods safely, and that the operational benefits could be scaled across the entire bomber force, fundamentally altering mission planning, resource allocation, and combat strategy. As commanders could now dispatch aircraft farther, heavier, and more efficiently, creating a strategic ripple effect that extended American air power deep into enemy-held territory. The results were staggering. Missions that previously required careful fuel rationing, reduced payloads, or risk-laden detours could now be executed with heavier loads, longer ranges, and improved survivability, catching enemy forces off guard, enabling strikes on previously untouchable targets, and allowing reconnaissance planes to gather intelligence over vast, hostile regions, all while conserving critical resources and maintaining operational tempo, a direct consequence of pilots mastering the engine-killing technique with discipline, courage, and precision. Legend grew around these missions, as pilots recounted ghost-like glides over enemy positions, the thrill of silent flight, the palpable tension of watching gauges, instruments, and winds while calculating every adjustment, and the satisfaction of returning safely despite the inherent risks, a combination of human skill, daring, and mechanical ingenuity that would define a new era of aerial warfare, proving that controlled engine throttling could double operational range, extend mission reach, and redefine the limits of existing aircraft, embedding a narrative of suspense, triumph, and technical mastery into the history of aviation, and leaving a lasting lesson for generations. Survival and dominance sometimes depend not on raw power, but on calculated silence, precise control, and the audacity to exploit the limits of both man and machine in the pursuit of extraordinary outcomes. As the war reached its most critical stages, the engine-killing technique evolved from daring improvisation into a defining hallmark of U.S. aerial strategy, a method that allowed bombers to fly farther, strike harder, and survive where previously such missions would have been impossible. And it was in these climactic moments that the true genius and peril of the technique became fully apparent, as pilots faced long stretches over open ocean, hostile territory, and unpredictable weather, relying not on brute power but on precise throttle management, glide angles, and acute awareness of environmental factors. a discipline that tested the limits of human skill, endurance, and nerve, transforming each flight into a high-stakes experiment in physics, aerodynamics, and tactical ingenuity, where every adjustment of the throttles, every minor input on the rudder or elevator, could determine whether the crew returned safely or vanished into the unforgiving expanse below. And yet, despite the risk, the rewards were staggering, allowing bombers to double their operational range, carry heavier payloads, execute more daring strikes, and gather intelligence in regions previously considered unreachable, fundamentally redefining what was possible in the skies above the Pacific, creating a strategic advantage that shifted the calculus of warfare, forcing enemy forces to react to aircraft that could seemingly defy fuel limitations, appear silently in unexpected locations, and retreat intact despite the vast distances traveled. Crews honed their techniques with relentless precision, learning to read subtle cues from instruments, wind currents, and engine behavior, coordinating every action among pilot, co-pilot, navigator, bombardier, and flight engineer, developing a level of teamwork and situational awareness unprecedented in military aviation. While ground crews and mechanics meticulously documented every flight, monitoring engine strain, fuselage stress, fuel consumption patterns, and structural wear, adjusting maintenance protocols and implementing design tweaks to ensure safety and reliability, creating a perfect synergy between human skill and mechanical endurance, where improvisation became codified procedure. Experimentation turned into standard practice, and what began as a desperate gamble became a disciplined, repeatable, and scalable method across multiple squadrons, ensuring that every aircraft could exploit this remarkable technique safely and effectively. The psychological dimension of these missions cannot be overstated, as pilots learned to remain calm under intense pressure, interpret subtle changes in sound, vibration, and airspeed, and make instantaneous decisions that determined the outcome of the flight, cultivating courage, precision, and adaptive thinking that would influence generations of aviators, and transforming the very act of flying into an exercise in calculated suspense, where mastery of throttle, glide, and environmental understanding became more important than raw engine power, and where success required both courage and intellect in equal measure. A lesson dramatized by countless missions in which bombers glided almost silently over enemy territory, their engines barely audible, flak bursting below, fighters scanning in confusion, and crews returning home with both lives and payload intact. A testament to skill, nerve, and the audacity to defy conventional limitations. In the broader scope of the Pacific theater, these advancements altered strategic possibilities dramatically, enabling longer-range strikes, heavier bomb loads, extended reconnaissance, and more efficient resource utilization, creating operational advantages that were impossible to achieve through standard procedures, forcing planners to rethink supply lines, mission planning, and enemy engagement strategies, and embedding the engine-killing method into the core of American aerial doctrine, ensuring that the lessons learned would endure far beyond the war itself, influencing post-war aviation, flight training, and the understanding of how human ingenuity can extend machine capability in ways previously thought impossible. The legacy of this technique also resonated on a personal level for the pilots and crews, as the adrenaline, tension, and exhilaration of executing precise throttle management over hostile territory became a shared experience that bonded crews, instilled confidence, and forged a culture of excellence, discipline, and daring that defined the airmen who mastered the skies with both caution and audacity, turning what once seemed reckless into a hallmark of operational brilliance and proving that calculated risk, when executed with knowledge, skill, and trust, could redefine the limits of human and machine performance alike. Ultimately, the engine-killing method became more than a tactical maneuver. It was a symbol of innovation, courage, and the relentless pursuit of mastery, a technique that allowed men to achieve what machines alone could not, to extend their reach across vast oceans, strike unexpectedly, and return victorious, leaving an indelible mark on the history of aerial warfare, and providing a suspenseful, cinematic narrative of tension, risk, and triumph that would captivate audiences for generations, embodying the thrill of discovery, the terror of near failure, and the exhilaration of overcoming the impossible, culminating in the haunting yet triumphant truth. U.S. pilots had learned to silence their engines, manipulate physics, and soar farther than ever before, transforming ordinary bombers into instruments of extended reach and silent power, and in doing so, had forever rewritten the boundaries of human ingenuity. Courage and aerial dominance, leaving a story of suspense, daring, and innovation that would resonate in the skies of history and the minds of all who dared to follow their flight.